March 3, 1945. 22,000 feet above the Rhine Valley. 02:17 hours. The darkness was absolute. No moon penetrated the cloud deck stretching from France to the North Sea. No starlight reached the cockpit of Major Robert Jensen's P-61 Black Widow as it prowled through the night sky over western Germany. The only illumination came from the faint green glow of the instrument panel, casting Jensen's face in an ethereal phosphorescence that made him look like a ghost, piloting a ghost ship through an invisible world. Behind him in the radar operator's position, Lieutenant Thomas Chen hunched over the AN/APG-10 radar scope, watching the cathode ray tube paint electronic echoes of the sky in sweeping green traces that revealed what human eyes could never see. The invisible architecture of the night, rendered visible through radio waves and vacuum tube electronics. The sound that dominated the cockpit was not the twin Pratt & Whitney R2800 engines, their 18 cylinders throttled back to cruising power, but rather the steady electronic hum of the radar set, a low-frequency tone that seemed to resonate in the bones, the audio signature of electromagnetic pulses being transmitted into the darkness and returning with information about the world beyond vision's reach. That hum was the sound of technological dominance, of American industrial and scientific capability, manifesting as the power to see in total darkness, to hunt enemies who believed themselves invisible, to transform night from sanctuary into hunting ground, where German aircraft attempting to move under cover of darkness became prey for hunters they could not see, could not hear, and could not comprehend. Chen's voice came through the intercom, calm and professional despite the information he was conveying. Contact bearing 350, range 8 miles, altitude 21,000. Closing. The radar had detected an aircraft ahead and slightly above them, its metal surfaces reflecting radio waves back to the P-61's receiver, transforming an invisible aircraft into coordinates and vectors that Chen's training allowed him to interpret and communicate. Jensen acknowledged with a click of his microphone switch, adjusted course 5 degrees left, and began a slow climb that would position the Black Widow beneath and behind the contact, the classic stern attack position from which the enemy aircraft would be silhouetted against any ambient light from above, while the P-61 remained invisible against the darker earth. Below 6 miles, 5 miles, 4 miles, the range decreased with mechanical inevitability as the Black Widow closed on its prey, guided by electronic eyes that saw through darkness and clouds with the same clarity that human eyes saw in daylight. At 2 miles, Jensen's radar-directed gun sight began painting targeting information onto his windscreen, invisible equations solved by analog computers transforming radar data into firing solutions. At 1 mile, he could finally see his target with biological eyes, a Junkers Ju-88 night fighter, recognizable by its distinctive silhouette, flying straight and level, its crew completely unaware that death approached from below. Guided by technology they did not know existed, Jensen armed his 420mm cannons, centered the gun sight pipper on the Ju-88's fuselage, and at 600 yards, a range where his cannons were devastatingly effective but where the German crew had perhaps 3 seconds to react before the shells arrived, he pressed the trigger. The Black Widow shuddered as the 4 Hispano cannons opened fire, their combined muzzle flash briefly illuminating both aircraft in a strobe of orange-yellow light, their shells walking up the Ju-88's wing root and fuselage with mechanical precision. The German aircraft's fuel tanks erupted in flame, transforming the darkness into a sphere of orange light that must have been visible for 50 miles, that illuminated 4 faces in the Ju-88's cockpit, frozen in expressions of incomprehension. How had they been found? How had the enemy seen them in absolute darkness? How had death materialized from the night without warning or opportunity for defense? The Ju-88 fell away in a burning spiral, trailing a comet tail of flame as it tumbled toward the Earth 20,000 feet below. Jensen did not watch it impact, had already resumed search pattern while Chen's radar swept the sky for additional contacts. The entire engagement had lasted 4 minutes from initial detection to kill, a mathematically precise execution that reduced aerial combat from test of pilot skill and aircraft performance to a problem of search, detection, and weapons employment, a transformation that the German crew would never understand because they died without comprehending that their enemy possessed electronic eyes that could see through darkness. Itself, this technological asymmetry American, Radar-equipped night fighters hunting German aircraft that relied on biological vision in conditions where vision was useless represented one of World War II's most decisive yet invisible advantages. It exemplified how American industrial capacity, scientific innovation, and institutional competence combined to create capabilities that transcended traditional military excellence. The radar hum in Jensen's cockpit was not just electronics operating. It was the sound of epistemological revolution, of warfare transformed by the mastery of invisible portions of the electromagnetic spectrum, of German military aviation being systematically destroyed by an enemy operating from principles that German tactical doctrine could not counter because it could not comprehend the technology enabling American dominance. To understand the magnitude of this advantage, one must first grasp the evolution of night fighting as a specialized domain of aerial warfare. Night operations had been attempted since World War I, but effective night combat had remained extremely difficult due to fundamental limitations. Darkness made navigation challenging, target detection nearly impossible, and even when enemy aircraft were spotted visually, engaging them required exceptional skill and substantial luck. Between the wars, various nations explored night fighting techniques, developing specialized aircraft with enhanced visibility from the cockpit, training pilots in night navigation and combat, and attempting to coordinate with ground-based searchlights and sound locators to position night fighters near enemy bombers. These pre-radar techniques achieved limited success at enormous effort. Searchlights could illuminate enemy bombers if they were precisely positioned and if atmospheric conditions permitted, but bombers could take evasive action or simply fly above searchlight range. Sound locators could detect aircraft by engine noise, but only provided approximate direction, and were useless in combat zones where multiple aircraft operated simultaneously. Visual detection required exceptionally keen eyesight, favorable atmospheric conditions, and usually some form of ambient light, moonlight, searchlight reflection, or the glow of fires below. Even under optimal conditions, visual night fighting was more art than science, with success depending on pilot intuition, experience, and luck in measures that made systematic effectiveness nearly impossible. The introduction of radar transformed night fighting from uncertain art to systematic science. British development of airborne intercept radar in 1940-1941, driven by desperate need to counter German night bombing during the Blitz, proved that radio waves could detect aircraft at ranges exceeding visual detection, even in perfect conditions, and could do so regardless of darkness, clouds, or atmospheric conditions. Early British AI, airborne intercept radars, were crude with limited range and poor resolution, but they enabled night fighters to find and engage German bombers with effectiveness that searchlights and sound locators could never achieve. By 1942-1943, British night fighter defenses had made German night bombing prohibitively expensive, forcing the Luftwaffe to abandon systematic night operations over Britain. American entry into radar development brought characteristic approaches, systematic research, industrial-scale production, and institutional commitment to deploying technology at operational scales. The MIT Radiation Laboratory, established in 1940 specifically to advance radar technology, became the center of American radar innovation. By 1943, American researchers had developed microwave radar systems operating on centimeter wavelengths, providing far superior resolution and range compared to earlier meter wavelength systems. The SCR-720 airborne intercept radar, developed for the P-61 Black Widow night fighter, represented the cutting edge of American radar technology, capable of detecting bomber-sized targets at ranges exceeding 15 miles, with sufficient resolution to guide fighters to within visual range even in absolute darkness. The P-61 Black Widow itself represented American institutional commitment to specialized night fighting capability. Designed from inception as a radar-equipped night fighter, the Black Widow incorporated lessons from British experience while adding American engineering refinement and industrial production capability. It was large for a fighter, twin-engine, three-crew configuration, reflecting the reality that effective radar required space for equipment and a dedicated operator. It was heavily armed with 4 20mm cannons and 4 50 caliber machine guns, providing firepower to destroy bombers quickly before they could take evasive action. It was painted matte black to minimize visual detection. Most importantly, it was produced in sufficient quantities, and deployed with adequate training and support to make American night fighting systematic rather than opportunistic. Major Jensen had transitioned to night fighters in mid-1944 after flying day fighters in the Mediterranean theater. The shift required relearning fundamental aspects of military aviation, navigation by instruments and radio aids rather than visual landmarks, formation flying by reference to instruments rather than visual positioning, and perhaps most challenging, learning to trust the radar operator whose information about the unseen world beyond the cockpit determined tactical decisions. The radar operator became the mission-critical crew member, with the pilot essentially executing maneuvers that the radar operator directed based on information invisible to the pilot. This inverted traditional cockpit hierarchy, requiring pilots to subordinate their instincts and situational awareness to electronic information they could not directly verify. The training emphasized the radar system's capabilities and limitations. The AN/APG-10 radar could detect large aircraft at ranges up to 15 miles in optimal conditions, but range decreased with target size, atmospheric conditions, and the presence of ground clutter that created false returns. The radar operator learned to interpret the phosphorescent traces on the cathode ray tube to distinguish actual aircraft from spurious returns, to estimate target altitude and heading from the radar presentation, and to direct the pilot toward intercept geometry that positioned the night fighter for visual identification and weapons employment. The system worked, but it required crew coordination, technical competence, and institutional support that not all military organizations could provide. German awareness of Allied radar development was fragmentary and incomplete. German scientists understood radar principles, had developed their own radar systems for air defense and naval applications, and by 1943 recognized that Allied aircraft might carry airborne radar. But German understanding of the sophistication and operational deployment of Allied airborne radar lagged badly. German night fighters, primarily the Ju-88 and later the He-219, carried their own radar systems, the Liechtenstein series, which provided intercept capability against Allied bombers. But these systems operated on longer wavelengths than American microwave radars, were more susceptible to Allied electronic countermeasures. And by 1944-1945, German radar technology had fallen significantly behind Allied developments. More fundamentally, German night fighter doctrine emphasized visual engagement once radar or ground control had positioned fighters near bomber streams. German pilots were trained to close to visual range, visually identify targets to ensure they were attacking enemy bombers rather than friendly aircraft, and engage using visual gunnery. This doctrine made sense when German night fighters were attacking Allied bomber streams over Germany, where ground control could provide general positioning, and where bomber streams were dense enough that finding visual targets was feasible once in the approximate area, but it left German aircraft vulnerable to Allied night fighters employing different tactics, using radar to find, track, and engage targets without ever achieving visual contact before weapons employment. The psychological impact on German night fighter crews was devastating. They flew missions believing that darkness provided concealment, that by avoiding searchlights and known Allied night fighter patrol areas, they could operate with reasonable safety. Instead, they were being shot down without warning, destroyed by enemies they never saw, killed by weapons fired from aircraft whose presence they never detected. The only warning was often the muzzle flash of attacking aircraft's cannons, a brief strobe of light revealing the hunter an instant before the hunter's shells arrived. Survivors who bailed out could report only that they had been attacked without warning from darkness, that they had never seen or heard their attacker before weapons impact, that the enemy seemed to possess uncanny ability to find targets in conditions where visual detection should have been impossible. German technical intelligence attempted to understand what was happening. Analysis of crashed Allied night fighters revealed radar equipment, and captured documents provided some information about Allied night fighting techniques. But understanding that the enemy possessed airborne radar did not enable effective countermeasures. Germany lacked the electronic warfare capabilities to jam or deceive Allied radar systematically. German aircraft could not detect Allied radar emissions in time to take evasive action. The Luftwaffe could not contest Allied night air superiority because Allied night fighters possessed systematic technological advantage that German tactics and technology could not counter. The hum of the radar set in Jensen's cockpit, that steady electronic tone produced by the transmitter's power supply and modulation circuits became the auditory symbol of this technological dominance. It was always present during night operations, a constant reminder of the electronic system that made the mission possible. Jensen learned to tune out the sound during routine patrol, but it remained subliminally present, and during engagements it seemed to intensify even though its actual volume remained constant, as if the radar's importance to the mission's success made it sound more psychologically salient. The sound represented more than just functioning equipment. It represented the entire institutional and industrial infrastructure that had created the radar, trained its operators, maintained its operation, and integrated it into effective night fighting doctrine. Behind that hum was the MIT Radiation Laboratory's research, the industrial production of sophisticated electronics by companies like Western Electric and General Electric, the logistics networks that delivered spare parts and maintenance support to operational units, the training programs that produced competent radar operators, and the command structure that employed night fighters systematically, rather than experimentally. The hum was the audio manifestation of American technological civilization operating at the frontier of scientific knowledge and translating that knowledge into operational military capability for German aircrew encountering American night fighters. There was no corresponding sound to warn them of danger. The radar waves were invisible and silent, propagating at the speed of light, reflecting from aircraft surfaces without producing any sensation that crews could detect. The Black Widow's engines were audible, but at typical engagement ranges and with the target aircraft's own engines running, the approaching night fighter was acoustically indistinguishable from background noise. The first and often only warning was the sound of cannon shells impacting the aircraft, a sound that many crews never consciously registered because the shells killed them. Before their nervous systems could process the auditory information, the tactical geometry that Jensen and Chen employed was refined through systematic analysis of what worked and what didn't. The stern attack from below remained the standard approach. It positioned the night fighter in the target's blind spot, used the Earth's darkness to conceal the attacker, and provided a relatively stable firing solution. The radar guided the entire approach, with Chen providing range, bearing, and altitude corrections that Jensen translated into course and altitude changes, bringing the Black Widow to within visual range without the target aircraft's crew detecting anything unusual. Only at the final moment, when Jensen achieved visual identification and positioned for weapons employment, did the engagement transition from electronic hunt to traditional aerial combat, though by that point, the outcome was essentially determined. The lethality of this system was reflected in the statistics. The 422nd Night Fighter Squadron, which Jensen served with, claimed over 50 German aircraft destroyed between September 1944 and May 1945, with the majority killed using radar-directed stern attacks where the target aircraft showed no evidence of detecting the threat before weapons impact. Loss rates for the night fighter squadrons were remarkably low, far below day fighter or bomber loss rates, because radar-equipped night fighters could avoid threats as effectively as they could find targets. A radar operator monitoring his scope could detect German night fighters attempting intercepts and guide his pilot away from threats, while simultaneously prosecuting attacks on targets that remained unaware of the American night fighters' presence. The strategic impact extended beyond simple attrition of German aircraft. The presence of American night fighters severely constrained Luftwaffe operations, forcing German aircraft to avoid flying at night even when tactical situations demanded it. German transport aircraft attempting to supply isolated garrisons or evacuate key personnel became increasingly vulnerable. American night fighters patrolled known routes, detected transports at long range, and destroyed them with systematic efficiency. German night fighter operations against Allied bombers became more hazardous as German night fighters themselves became hunted. Forced to consider that every mission might encounter an American night fighter they would never see until cannon shells announced its presence. The psychological pressure accumulated. German aircrew knew they were being hunted by an enemy possessing technological capabilities they could not match, creating stress and morale problems that degraded operational effectiveness, independent of actual combat losses. The night of March 3, 1945, when Jensen destroyed the Ju-88, was typical of these operations. The 422nd Night Fighter Squadron launched 4 Black Widows from their base in eastern France on patrol missions covering western Germany. Jensen's mission was to patrol the Rhine Valley, searching for German aircraft attempting to move personnel or supplies during hours when daylight operations had become suicidal due to overwhelming Allied air superiority. The patrol was routine, orbit along assigned tracks, radar operators searching their scopes for contacts, communications monitoring for vector information from ground control. The weather was terrible, solid cloud cover, no moon visibility, essentially zero conditions that made visual flight operations nearly impossible but were ideal for radar-equipped night fighters. The Ju-88 that Jensen destroyed was part of a German night fighter unit being relocated from northern Germany to an airfield in Bavaria, flying under conditions the crew believed provided concealment from Allied detection. The German pilot likely flew by instruments, concentrated on maintaining course and altitude, perhaps scanned the darkness periodically, but saw nothing because there was nothing to see visually. The radar operator, if the aircraft carried one, may have been monitoring his equipment, but would have had difficulty detecting the Black Widow against ground clutter and may not have realized the contact he was seeing represented a threat rather than another German aircraft. The crew probably believed they were relatively safe, flying at night, in bad weather, far from known Allied fighter bases, taking reasonable precautions. They were wrong because their understanding of the threat environment was fundamentally incorrect. They believed darkness provided concealment when American technology had made darkness transparent. They believed altitude and weather provided protection when radar operated effectively, regardless of atmospheric conditions. They believed reasonable tactical precautions would provide acceptable security when the enemy possessed systematic technological advantage that made traditional precautions irrelevant. Their deaths resulted not from tactical errors or lack of skill, but from fighting an enemy who operated from completely different technological foundations, who possessed capabilities that invalidated the tactical assumptions the German crew had been trained to rely upon. The engagement itself, 4 minutes from radar, detection to kill, illustrated the systematic efficiency of American night fighting doctrine. Every phase proceeded according to training and established procedures. Radar operator detected target, communicated information to pilot. Pilot maneuvered to intercept geometry. Radar guided closure to visual range. Pilot achieved visual identification, confirmed target was hostile, positioned for weapons employment, and engaged with overwhelming firepower that destroyed the target before it could react. The system worked not because of individual heroism or tactical brilliance, but because each component functioned as designed, because crew training enabled effective teamwork, and because the technology provided capabilities that made the outcome statistically probable rather than merely possible. Chen's radar scope, with its green phosphorescent display painting electronic representations of the invisible world, was the technological heart of this system. The AN/APG-10 radar transmitted pulses of microwave radio energy, received echoes from reflective surfaces, and displayed time-delayed returns as bright spots on the cathode ray tube. The scope provided range information directly, the distance from center to the displayed return, and bearing information by the return's position on the circular display. Altitude had to be inferred from the tactical geometry and the target's known approximate altitude. The entire display updated continuously as the radar antenna rotated, providing real-time tracking of contacts within the radar's range. Operating this equipment required technical competence and interpretive skill that only systematic training could provide. Radar operators learned to distinguish aircraft returns from ground clutter, weather returns, and electronic interference. They learned to track multiple contacts simultaneously, prioritizing threats and targets based on tactical considerations. They learned the radar's capabilities and limitations, that range decreased at low altitude due to ground clutter, that weather could create false returns, that the equipment required regular maintenance and calibration to function properly. Most importantly, they learned to communicate radar information to pilots in ways that enabled effective tactical employment without overwhelming the pilot with excessive detail. This crew coordination between pilot and radar operator represented a fundamental shift in aerial combat, where a crew member who never touched the flight controls became mission critical to tactical success. Traditional fighter aviation had been built around the pilot as sole decision-maker and executor, with any crew members performing subordinate roles. Radar-equipped night fighters inverted this relationship. The radar operator possessed information about the tactical environment that the pilot could not directly access, and effective prosecution of missions required the pilot to trust and act on this invisible information. The institutional challenge of training pilots to accept this role shift in training radar operators to perform effectively in mission-critical positions was as significant as the technical challenge of developing functional radar systems. German night fighter crews, working with their own radar systems, had developed similar crew coordination practices. But German radars lagged technically behind American systems. German training was increasingly abbreviated as the Luftwaffe's institutional capacity collapsed under sustained attrition. And by 1945, German night fighters were increasingly isolated, flying missions without the ground control support and systematic coordination that had previously enabled effective operations. German night fighter effectiveness declined not just because American night fighters were hunting them, but because the institutional infrastructure supporting German night operations had degraded under the cumulative pressures of sustained combat and strategic defeat. The sound of Jensen's radar, that steady electronic hum, continued through the night as the Black Widow resumed patrol, searching for additional contacts. The mission would continue until fuel state required return to base, or until mechanical issues forced early return, or until the patrol time expired according to mission planning. Chen's eyes remained fixed on the radar scope, watching the green sweeps paint and repaint the electronic picture, searching for the bright spots that would indicate another contact, another target, another opportunity to demonstrate the systematic technological advantage that American night fighters possessed. The cumulative effect of hundreds of missions like this, conducted night after night by multiple squadrons operating across the theater, was strategic suppression of German night air operations. German aircraft attempting night missions faced unacceptable loss rates to an enemy they could not effectively detect or counter. German commanders learned to avoid night operations when possible, to concentrate flights in time and space, hoping that overwhelming numbers would allow some aircraft to reach objectives, and to accept that night sky was no longer safe operational environment. This suppression of German night operations contributed to broader Allied air superiority, making daylight operations suicidal for the Luftwaffe and increasingly risky even at night, leaving German forces without effective air support or air transport capability during the war's final months. The technological basis for this dominance, the radar systems, the airborne platforms, the training infrastructure, and the institutional competence to employ them effectively, reflected systematic advantages that democratic industrial societies possessed over authoritarian alternatives. American institutions could conduct long-term scientific research, could translate research into operational technology, could produce complex systems at industrial scale, and could train personnel to employ technology effectively. Nazi Germany had experienced scientists and engineers, had industrial capacity, and had military organizations, but the regime's institutional dysfunctions prevented effective coordination between research, production, and operational employment. The result was technological lag in critical areas like radar, where American capabilities pulled increasingly far ahead of German equivalents as the war progressed. Jensen's return to base after completing the mission followed the same systematic procedures as the hunt: navigation by radio aids and instruments, approach and landing guided by ground control radar and radio communications, post-flight debriefing where the mission's details were recorded for intelligence analysis and tactical refinement. The destroyed Ju-88 was logged as a confirmed kill based on visual observation of its destruction, added to the squadron's record, and reported up the command chain where it became a data point in assessments of German air order, of battle and operational capability. The bureaucratic documentation of the kill, like the radar-guided hunt that produced it, reflected institutional systematization that made American military operations increasingly effective as organizational learning accumulated. For the German crew of the destroyed Ju-88, there was no return to base, no debriefing, no opportunity to report what had happened. They died without understanding what killed them, became casualties recorded in Luftwaffe records with minimal detail, lost to enemy action, no further information available. Their deaths contributed to German attrition statistics that showed unsustainable loss rates, that indicated German air operations had become infeasible, that demonstrated Allied air superiority had become absolute. But the individual tactical details, that they had been hunted with radar, detected at long range, tracked through darkness, and destroyed by an enemy they never saw, these details were unknown to German higher command and would remain unknown until after the war, when analysis of American capabilities revealed the technological asymmetry that had made German night operations so hazardous. That were the radar's hum in American night fighter cockpits continued through the war's final months. The sound of technological dominance made audible the audio signature of electromagnetic mastery that had transformed darkness from equalizer to advantage. That hum was present on thousands of missions, in hundreds of aircraft operated by crew members who understood they possessed capabilities their enemy could not match. It was the sound of American scientific and industrial achievement, translated into military effectiveness, of research institutions and production facilities and training programs all functioning in coordination to create and sustain complex operational capabilities at scale. Most fundamentally, it was the sound of epistemological revolution, the transformation of warfare through mastery of invisible portions of the electromagnetic spectrum, the practical demonstration that seeing the invisible provided decisive advantage regardless of traditional measures of military excellence. The Germans never knew, at least not until after defeat, the full extent of American night fighting capabilities. They experienced the effects: aircraft destroyed without warning, operations becoming impossibly hazardous, night sky becoming contested space rather than safe sanctuary. But the technological foundation for these effects remained invisible to them, just as the radar waves themselves were invisible, propagating silently through the darkness to return with information that gave American night fighters what approached omniscience within the radar's range. The invisibility of the technology that enabled American dominance was itself a form of advantage. German forces could not effectively counter what they did not fully understand, could not develop appropriate tactics against capabilities they had not fully characterized, could not provide their air crew with adequate warnings about threats whose nature they had not comprehended. In post-war decades, as the technology became public knowledge and radar became ubiquitous in civilian and military aviation, the revolutionary nature of wartime radar-equipped night fighters faded from consciousness. Radar became expected, normal, taken for granted as baseline capability rather than recognized as the war-winning advantage it had been. But for those who had been there, who had hunted with radar or been hunted by radar-equipped enemies, the experience remained formative. Jensen would spend decades processing the psychological implications of missions where he killed enemies who never knew they were being hunted, where technological advantage rather than personal skill determined outcomes, where the line between systematic military operations and something approaching technological predation became uncomfortably blurred. The sound of the radar, that electronic hum that permeated every mission, remained in Jensen's memory as the defining audio signature of his wartime experience. It was present in dreams, in moments of unexpected recollection, in the persistent tinnitus that aging would bring, and that seemed somehow connected to hours spent in cockpits with electronic equipment humming in his ears. But beyond personal memory, that sound represented historical significance. It marked the moment when warfare transformed from domain of human perception and physical courage to domain where electronic systems and technological sophistication determined outcomes regardless of individual warrior qualities. The hum of radar was the sound of modernity arriving in aerial warfare, of industrial civilization's advantages manifesting in ways that traditional military cultures could not counter, and of the future announcing itself in frequencies beyond human hearing, but with implications that would reshape how nations competed and how wars were fought. The night sky over Germany in 1945, seemingly empty and silent, was actually filled with invisible electromagnetic waves, radar pulses seeking targets, radio communications coordinating operations, navigation beacons guiding aircraft through darkness. This invisible infrastructure of electromagnetic energy represented a new kind of battlefield, one where control of the electromagnetic spectrum mattered as much as control of physical terrain, where the side that could see invisible dimensions possessed advantages as decisive as any traditional military superiority. The Germans never knew American night fighters used radar to hunt them in total darkness. But even if they had known, even if they had fully understood the technology and its implications, their knowledge would have provided little advantage because they lacked the institutional capability to develop equivalent technology, deploy it at operational scale, and employ it with the systematic effectiveness that American forces achieved. The hum of Jensen's radar, echoing through cockpits on missions across months of operations, was ultimately the sound of victory approaching through technological advantage, through American industrial capacity creating capabilities that enemies could neither match nor effectively counter, through the systematic application of scientific knowledge to military problems in ways that authoritarian regimes could not replicate. That hum announced to anyone listening that the war's outcome was determined not just by numbers of soldiers and weapons, but by the underlying institutional competencies that enabled one side to see in darkness while the other remained blind, to operate with systematic effectiveness while the enemy improvised desperately, and to maintain complex operations at scale while enemy capabilities degraded under sustained pressure. It was the sound of the future, of warfare transformed by technology, of battles fought in invisible dimensions, and of victory achieved through advantages that transcended courage, skill, and traditional military virtues, advantages rooted in the institutional and industrial capabilities that democratic societies developed and authoritarian alternatives could not sustain.